Section 5.4. Section 5.4 is on scientific notation. So we notice that we've got a lot of numbers that are really big. So if we were looking at 3, 4, 5, 0, 0, 0, 0, 0, 0, 0, 0, we notice that would wind up being 34 billion, 500 million, which winds up being a really big number. And if we have to use it a lot, we don't have to rewrite that over and over again. And so what we end up noticing is that we can choose to write it in scientific notation takes the number and rewrites it as a times 10 to the nth, where a is a value greater than or equal to 1, and less than 10. So we're saying 1 less than or equal to a less than 10. And so we notice that 34 billion 500 million we could write as 3.45 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th. And why did we pick 10? We picked 10 because we count off from where we could imagine 0.0 being. We could imagine as being 34 billion 500 million 0, and we count off 1 space, 2 space, 3 spaces, 4, 5, 6, 7, 8, 9, 10. And we notice if we count that way, we have to be very careful. If you do it too fast, it's easy to get confused. So let's look at one that's a little bit smaller. If we were going to look at, say, 42,000, we know this is a little bit easier to work with. We can think of that as being 42,000.0. To turn it into a number between 1 and 10, we would need to get 4.2. So that means the decimal point would have to move 1, 2, 3, 4 places to the left. And so we notice that we can write that as 4.2 times 10 to the 4th. So then we can also take a number inside of scientific notation, and turn it back into a regular number. If we had 9.17 times 10 to the 5th, we notice that we're just moving that decimal point 5 places back to the right. So we're getting 917 and then 0, 0, 0. We're imagining that decimal point moving 1, 2, 3, 4, 5 places to the right. We can also use it with n being negative. If we were going to look at 4.3 times 10 to the negative second, we notice now it just means that we're moving this point to the left. And so we would get, we imagine that 4.3, this point goes 1, 2 to the left, and so we would get 0.043. And so using those negative exponents winds up being helpful for dealing with very tiny numbers. If we had 0.0000027, we notice that we start with 2.7, So we start by writing as a number between 1 and greater than or equal to 1, less than 10. And then we count the decimal points, or count the decimal places. So we need to move the decimal point 1, 2, 3, 4, 5, 6, 7 places to the right. And so we're going to say times 10 to the negative 7th. So we're noticing if we're trying to move the decimal point to the left, we're going to get a positive exponent. And if we're trying to move our decimal point to the right, we're going to get a negative exponent. So a lot of this just takes practice. So just to compare, we notice that if we're going to take 5.3 times 10 to the third, that would give us 5300, so 5300. But 5.3 times 10 to the negative third would give us 0.0053. And we're just counting those 3 decimal places this way. So at this point we'd have to move 1, 2, 3 to the right, and so we get 5.3 times 10 to the negative third. And then the other direction, if we had 40, let's use 7300, that would be 7.3 times 10 to the third. And if we had 0.00073, that would be 7.3 times 10 to the negative 1, 2, 3, 4. 10 to the negative 4th. And again, we're just counting. Something we probably won't have to do a bunch of, but is worth being aware of, is if we were going to try to multiply numbers in scientific notation, if we were going to take 4 times 10 to the 5th times 3 times 10 squared, we notice this works a lot like multiplying variable expressions. We notice that we're going to take those a values, the 4 and the 3, and multiply those separately from the 10 to the 5th times 10 squared. So we notice that the 4 times 3 just gives us 12, and then that'll be times 10 to the 7th. You notice, though, that's not going to be our standard form for scientific notation, and so we're going to think of that 12 as being 1.2 times 10 to the 1st times 10 to the 7th, which then gives us 1.2 times 10 to the 8th. So if we had something a little more exotic, we could try looking at 5.1 times 10 to the 5th times 2.3, 2.3 times 10 to the 4th. We notice that we're going to get the 5.1 times 2.3 we have to do separately. 5.1 times 2.3 we multiply normally, get 3, 15, 2, 10, gives us 3711, so we're going to get 11.73. So we get 11.73 times 10 to the 5 plus 4, but again, we're going to think of that as being 1.173 times 10 to the 1st times 10 to the 9th, and so then that winds up being 1.173 times 10 to the 10th. And then similarly, we can do that with division. If we had 4 times 10, 4 times 10 to the 5th divided by 2 times 10 squared, we notice that we're going to get that 4 divided by 2 times 10 to the 5 minus 2, and so we just get 2 times 10 to the 3rd. So the only place where that gets a little bit trickier is if we were going to look at something like 1 times 10 to the 3rd divided by 4 times 10 to the 5th. we notice that's going to wind up being 1/4 times 10 to the negative 2. And so we have to be a little bit careful with that, because that would wind up being 0.25 times 10 to the negative 2. And again, if we want that in standard form, we think of that as 2.5 times 10 to the negative 1 times 10 to the negative 2. And so that's going to be 2.5 times 10 to the negative 3. And again, if you're using a calculator, this winds up being a lot more straightforward. We don't have to think about it too hard.